This is the first part of multiplying decimal numbers. In this part, we will see how to multiply decimal numbers by a whole number. First, we will see some examples and then we will go over the steps or the rules to do such multiplication. Let's look at this first example. 0.7 multiplied by 5. We do not know yet how to multiply a decimal number by a whole number, but we do know how to multiply a fraction by a whole number, and we also know how to convert a decimal number to a fraction. Let's use what we know and do the multiplication. So 0.7 when converted to a fraction becomes 7/10. That means the multiplication would be 7/10 multiplied by 5. We can multiply this. 7 5s are 35 and the denominator remains the same. So the answer is 35/10. If we convert this back to a decimal number, it would be 3.5. Why? Because 35/10 is equal to 3 and 5/10, which is equal to 3.5. Let's consider another example. 1.2 multiplied by 30. Again, let's follow the same steps. This equals to 12/10 multiplied by 30, which is equal to 12 3s are 36. So 12 multiplied by 30 equals 360. So the product is 360/10, which is equal to 36.0. That means 36. If you look at these two products, these two multiplications that we just now did, we can figure out some rules to do this kind of multiplication without converting them to fractions. The first thing what we can do is that you can ignore that there is any decimal point there and multiply the numbers normally. Okay, assume that the decimal point is not there. For example, in the first problem, we just multiply 7 and 5 and the product will be 35. In the next step, we can put the decimal point in the product. How do we do that? We count the number of decimal places in the original decimal number, the one you multiplied. So in the first example, the number of decimal places in 0.7 is equal to 1. When we put the decimal point in the answer, in the product, we make sure that it has the same number of decimal places as the decimal you multiplied. That means in 35, we put the decimal point in such a manner that it would also have one decimal place. That means the answer would be 3.5. Same is the case in the next example. You can see that 12 multiplied by 30 would be 360. And in 1.2 there is only one decimal place. So in 360 we put the decimal point in such a manner that there is only one decimal place, and that would make the answer 36.0, which is equal to 36. So if we use these rules, then we can multiply any decimal by any whole number. Every time we do not need to convert this to a fraction and then multiply and then convert it back to a decimal number. We don't need to do that. So let's look at the next example. 5.4 multiplied by 6. Let's ignore the decimal point and multiply 54 and 6. 54 multiplied by 6. Let's work it out. 6 4s are 24. So we write down 4 and 2 is carried over. 6 5s are 30. 30 plus 2 equals 32. So the product is 324. Now let's look at 5.4. We see there is only one decimal place. So in 324, what we do is we make sure that there is only one decimal place. Hence the answer is 32.4. Let's solve some more problems. 4.7 multiplied by 10. Again, ignore the decimal point. So we multiply 47 and 10. 47 tens are 470. Now look at 4.7. There is only one decimal place. So in the product we do the same thing. The answer is 47.0, which is equal to 47. The next example is 93.2 multiplied by 100. Again, ignore the decimal point. So 932 multiplied by 100 equals 93,200. Look at 93.2. There is only one decimal place. So let's do the same thing for the product. So the product is 9320.0, which is equal to 9320. Now if you look at these two examples, the last two examples, you can see that they are simpler than the previous problems. What I mean is that multiplying by 10 and multiplying by 100 is easier than multiplying by some other number. Do you notice something here? Why is it simple? If you consider 4.7 multiplied by 10, you can see that the decimal point just hops over 7 and moves to right, and thus the answer is 47.0 or 47. In case of 93.2 multiplied by 100, the decimal point hops over 2 digits, but there is only one digit there. You can see that there is 93.2, but we know that 93.2 is same as 93.20. So I can say that the decimal point hops over 2 digits and moves to the right, so that I can get the answer as 9320.0. So what we understand here is that multiplying a decimal number by 10, 100, 1000, 10,000 and so on is pretty easy. If the multiplier means the number that multiplies. If the multiplier is something like 10, 100, 1000, then what you do is you simply move the decimal point to the right by certain number of decimal places. If the multiplier is 10, you move to the right by 1 place. If it is 100, then you move 2 places, and so on. That means how many ever zeros are there after 1, those many places you move to the right. Let's use this chart and solve some more problems. 0.0053 multiplied by 100. Since the multiplier is 100, let's hop over 2 places. Let's move the decimal point to the right by 2 places. So the answer is 0.53. The next one is 1.267 multiplied by 1000. Since we multiply by 1000, we hop over 3 digits. So the answer is 1267. The next one is 0.33 multiplied by 1000. Again, the multiplier is 1000, so we have to hop over 3 digits, but there are only 2 digits here. So what do? We write an extra 0 after 33. We know that in case of a decimal number, if you put an extra 0 in the end, it does not change its value. So let's put that 0 and hop over 3 digit, and so the answer is 330. The next one is 465 multiplied by 100. Now where is the decimal point here? This problem is not about a decimal number. This is just a regular multiplication. This is given just for fun, just to trick you. So let's do the multiplication like any regular multiplication. When you multiply by 100, you put 2 extra zeros. So the answer is 46,500. But if you really want to see the decimal point here in this problem, where is the decimal point? The decimal point is here after 465. 465 is same as 465.0. Typically we do not write this decimal point and 0 in case of a whole number, but if you do want to write, this is the way it is written. So 465 can be written as 465.0, and you can still use the same logic. That is, when you are multiplying by 100, you move the decimal point to the right by 2 places. If you do that, the answer would be 46500, that means 46,500. So the chart that we learned here is applicable for whole numbers also.